Hi everyone. So in this video we'll discuss about very basic important logical programs. Those are not related to string or array, but those are mostly related to for loops and if else condition. So those are very important and very basic programs. So we'll start with the prime numbers. So how find the prime numbers between 1 to 100. So okay, let's understand definition of prime number is a number which is divisible by only one and number itself, right? Okay, so we will apply the logic as to check whether number is prime or not. We'll divide it by from 2 to number divided by 2. So when the number is divisible by 2 to num divided by 2, which means for example we have to check 25 as a whether it's prime or not. So we will execute one loop which will start from 2 to 25 divided by 2 will be 12, right? So the loop will execute from 2 to 12, and it will whether in between that if the number we get remainder as 0, then it's not prime number, right? Because the prime number should be only divisible by one and number itself, right? It should not be divisible by two other numbers from like that 2 to 12. Okay, so let's understand this how to print the numbers between 1 to 100. Okay, so this is our main method, and inside this main method this is our printing statement prime numbers between 1 and 100, and this is our for loop. It starts from integer number is equal to 2, num is less than or equal to 100, num plus plus, because we will be printing from 1 to 100, right? Okay, so then boolean is prime is equal to true, and this is we have initialized is prime a variable as a true initially, and whenever the condition will satisfy we will make it as a false, right? The condition as I explained here, whenever the when we get the number is divisible by the 2 to num divided by 12. In this logic, if the number is getting remainder as 0, then the number is not prime. That's why we have written as is prime is equal to false, and we will be breaking that loop. Okay, so let's understand how it works. So this is the outer for loop. Num is equal to 2, num is less than or equal to 100, num plus plus is prime is equal to true initially. Then inside this for loop it will start from integer I is equal to 2, I less than or equal to num divided by 2, I plus plus. And then in this for loop we have one condition: if num modulus to I, num modulus I is equal to 0. So num modulus I, this will give us the remainder. So when we divide this number with this I, that 2 to num divided by 12, right? So this loop will execute that number. So it will check for each iteration. If that's the remainder is 0, then is prime is false and it will break, right? And when the if is prime is true, then only it will print the number, because that will be is prime number, right? If it's true, then it's prime number. Okay, so let's understand very first for the very first iteration how it will work. So for very first iteration num is 2, so integer I is equal to it is prime is true. Then inside this for loop it will check num is 2 divided by 2, it will become 1. And when I is equal to 2 and I less than equal to 1, so this will not execute, this whole for loop will not execute, and it will print directly here is prime will be directly true, and it will print 2 because 2 is a prime number, right? It's not going inside this condition. Again for the next iteration num will be 3. Again here we get num is 3 divided by 2 will be 1, and again this for loop is we have initialized with I is equal to I less than equal to 1. Again this will be failing, so it will not print anything, and again here it will print 3 as a prime number, right? Again for the next iteration num will be 4, and here 4 divided by 2 will be 2. Now it will execute for one iteration, and in that one iteration we will get num as 4 modulus 2. 2 will be a 0, we will get remainder as 0, and it will make is prime as a false, and it will break the for loop. And is prime is now false, so it will not print 4. So this is how it will check the condition for all the numbers between 1 to 100, and it will print only prime numbers, right? So this is how it will print. So let's execute the code and check whether we have written code correctly, and it will print the prime numbers from 1 to 100. Yes, we are getting prime numbers between 1 to 100. So this is how we can print prime numbers, right? Yeah, that is it. Thank you. Hi everyone. So in this video we'll discuss about Armstrong number. Armstrong number is a number where the sum of each digit raised to the power of the total number of digits is equal to the original number. So what is mean by this definition? So for example, this is our number 153, and here when we raise for each digit 1 raised to 3 plus 5 raised to 3 plus 3 raised to 3. So when we find the cube of each and add them, and then we will get the number, original number, right here 153 we are getting. When we add at 1 plus 125 plus 27, it will be 153. So that number is referred as Armstrong number. It may be any digit, it may be 4 digit, it may be 2 digit. So this is our 153 is a Armstrong number, right? So when the number is of 4 digit, then we have to use each digit raised to 4. If the number is three digit, then 1 raised to 3, right? Like that way, and we will get the same number. So this number is referred as Armstrong number. So we will write the code to check whether the given number is Armstrong number or not. So this is our main method, and inside this main method we have taken integer num is equal to 153 and integer sum is equal to 0, integer num1. This is another variable where we have assigned value as a num, so the same value we have assigned here. What is the use of this? I will explain that in the end. At the end we need that. And another variable integer remainder, we have just declared it not initialized initially, and then we are using for loop. So this for loop is very important. Let's understand this. So we have given condition here for the while loop. So while loop starts with num is greater than 0. So whenever this number is greater than 0, the loop will execute, and when the number is greater than is less than 0, then it will not work, or even is equal to 0, it will not work, right? So let's understand inside the loop. A remainder is equal to num modulus 10. So what is mean by num modulus 10? It will give the remainder. So if we divide, for example, num is 153, right? 153 modulus 10 means it will give the remainder. So here remainder will be 3. So for the first iteration, we will get remainder as 3. Then num is equal to num divided by 10. So 153 divided by 10 will be 15. So here num will be 15. And then we have sum is equal to remainder into remainder into remainder. So we have used remainder 3 times because as per the definition, right, we have to use 3 times here. Each digit is a remainder raised to 3. So if the number is 4 digit, then we can use this 4 times like this way. And then sum, then we will add plus sum. So this will be the sum, we'll get the sum. Now for the first iteration, we get remainder as 3, then 3 into 3 into 3, it will be 27 plus sum, initially sum is 0. So some value will become as a 27 for the first iteration, right? Then for the next iteration, the num value is updated now, right? Num is 15, so 15 is greater than 0. Yes. Again, remainder is equal to 15 modulus 10. Here 15 modulus 10 means we get remainder as a 5, right? And then num is equal to num 15 divided by 10. Again 15 divided by 10 will get remainder as a num as a 1. So num value will be 1, and sum is equal to, now remainder is 5, so 5 into 5 into 5 will be 125 plus some value is 27, right? So 125 plus 27 will be 152. And again for the next iteration, we here we got a num is equal to 1, right? So num 1 is greater than 0, so condition satisfied. Again a remainder 1 modulus 10 will be 1, remainder will be 1, right? Again remainder value will be 1. Now num is equal to 1 divided by 10 will be 0, and sum is equal to 1 into 1 into 1 will be 1 plus 152 will be 153. Some value will become 153, and now here num value is 0. So next time num is 0, so 0 is not greater than 0, right? So condition fails, loop will not execute. Now at the end we will use num1. Here num1 is 53, right? Because we have initialized here as a num. So num1 is 53. We will check whether the original number, so this will be the original number, right? 153 is equal to sum. Sum is the final sum after addition and using 3 raised to 3, 5 raised to 3 plus 1 raised to 3, right? We got the final sum. If num1 is equal to sum, then it is a Armstrong number, right? And in the else condition, if the condition fails, it means it's not Armstrong number. So we have written num1 plus is not a Armstrong number, and in the if condition we have written is a Armstrong number. So let's execute the code and check whether we have written code correctly. So 153 is a Armstrong number, so it should print 153 is a Armstrong number. So I have executed the code and 153 is an Armstrong number. So let's change number to something else. Let's make it as something 123. So it's not Armstrong number, so it will return as 123 is not Armstrong number. So yeah, this is how we can print this is how we can check whether the given number is Armstrong number or not. Yeah, that is it. Thank you. We will discuss about Fibonacci series. It is a sequence of numbers where each number is the sum of the previous two numbers. Okay, so let's understand what is Fibonacci series. It starts with 0, 1, 1, 2, then 3, 5, 8. So this is referred as a Fibonacci series. So 8 after that it will come as 8 plus 5 will be 13, right? So it will be 13. 13 plus 8 it will be 21. So the sum of the previous two numbers is equal to the next number. So this is referred as Fibonacci series. 8 is the sum of previous two numbers, that is 5 plus 3, right? 5 is the sum of previous two numbers, 3 plus 2, like that. 2 is the no, sum of previous two numbers, like that. So this is referred as a Fibonacci series. So we have to write the code to check whether the print the Fibonacci series. Okay, so this is our main method, and inside this main method we have initialized variable integer num is equal to 0, num1 is equal to 1, and sum is equal to 0. So these are the three variables we need. And then we have printed system.out.print num, and we have not used ln, so we will be printing in the same line, right? Then this is the for loop. Here it starts with integer I is equal to 0, I less than 10, I plus plus. So this I have used here 10 so that it will print up to 10 iterations, means 10 digits it will print, right? Okay, so num is equal to num1. So let's understand the conditions here. So num is equal to num1, this num is equal to num1 here. Num1 will be sum is equal to sum, and sum is equal to num plus num1. So these are the very basic conditions. You have to just assign num with num1, and num1 is equal to sum, and sum is equal to num plus num1. And at the end we have to use printing statement system.out.print sum plus double inverted comma and space. We have to give the space so that it will be in the one line. We are not using ln. So let's execute the code and check it will print. So we got 0, 1, 1, 2, 3, 5. So this is referred as a Fibonacci series, and it's easy. We can easily print the Fibonacci series. It's very simple and a basic code, so everybody should know about this code Fibonacci series. It printed up to 55 because we have used here 10. If we make it as a 20, it will go long beyond that. So let's check for the 20. Yeah, it printed up to like 6765, like that. So for example, let's check 55. 55 is the sum of previous two numbers, right? 21 plus 34. So let's understand once this internal logic. So this is printing the 0 initial num. Then in the for loop, what is happening here? So num value is num initial is equal to num1. Num1 will be 1, so num value will become as 1, and num1 is equal to initially sum is 0, so num1 value will become as 0, and sum is equal to num plus num1. So num value is 0 here, 1, because we have initialized num1, right? So num value will be 1 plus num1 will be 0 because we have initialized sum. So num plus 1 plus 0 will be 1, so sum value will be 1. Then it will print sum value, which is 1, so it will print 1. Initially it printed 0 once, then in the for loop it started with printing 1. Then for the next iteration it will be num is equal to num1. So num1 value is 0 because we got last time 0, right? So num value will be 0, and then num1 is equal to sum, so sum value is 1, and then sum is equal to 0 plus 1 become 1. So again we will print sum, which is 1. For the next iteration, here we got num is equal to 1 because last time we got num1 as 1, right? So here num is equal to 1, num1 is equal to sum, which is 1, so sum will become 1 plus 1 will equal 2. So like this. Then for the next iteration we will get 3, then 3 plus 2 5, then 5 plus 3 8, like that. So this is how it will print the Fibonacci series. Yeah, that is how it will print the Fibonacci series. Yeah, that is it. Thank you. Hi everyone. So in this video we'll discuss about how to find whether the given number is prime number or not. So in the last example we already discussed how to find the prime numbers from 1 to 100. So in this video we'll discuss about how whether the given number is prime or not. So this is our prime number method, and inside this we have taken integer num is equal to 21, and boolean is prime is equal to true. So initially we have initialized is prime variable as true, and we have if else condition here. Inside the if condition we have written condition as if the number is less than or equal to 1, then is prime is equal to false. And and then we have printed this statement system.out.print number is prime, and it will check whether it's true or false. Okay, so in the if condition we have this condition, and in the else we have one for loop which checks the same logic as we have discussed in the last video. Here integer I is equal to 2, I less than or equal to num divided by 2. So here in this case it will check from 2 to 10 I plus plus, and if num modulus I, which means it will check the remainder. So num currently is 21 and I value is, it will change for each iteration from 2 to 10, right? And for each iteration, when a remainder will become 0, the condition will become true and is prime will become false. So the it will print 21 is prime false, right? So it's not prime, like that. So this is how it will work, and for each iteration it will check whether number divides or not, whether we'll get remainder as 0 or not, right? So let's execute and check for the 21 number. So 21 is prime, so it's false, right? So let's check for another number, 23. So it's prime number, right? So 23 is prime, true. So this is how we can check whether the given number is a prime number or not. Yeah, that is it. Thank you. So in this video we'll discuss about palindrome number. So what is palindrome number? It is a number that remains same when its digits are reversed. For example, this is 1011, this is number. When we reverse the number, it will be like this, 1101, right? So it's not like that of the original number, so it's not a palindrome number. So we have another example, 1001. So when we reverse this number, it will be like 1001, right? So this is referred as a palindrome number. When we reverse the number, then it will be same as the original number. So that number is referred as a palindrome number. So we have to write the code to check whether the given number is a palindrome number or not. So this is our main method, and inside this main method we have taken integer num is equal to 12321. So we have to check this given number is palindrome or not. So for that we need a variables integer num1 is equal to num. So we have referred num1 is equal to num. We are just giving the same value for num1, right? Then integer remainder comma sum is equal to 0. So we have just declared remainder and initialized sum is equal to 0. So let's understand this while loop here. So in the while loop we have condition number is greater than 0. So this number, when it's greater than 0, then only this loop will execute. So this while loop, it's very important. Let's understand the conditions inside the while loop. So here remainder is equal to num modulus 10. So a num modulus 10 will give us the remainder. So when we divide, when we use the modulus, we will get the remainder. So for this number, when we use 10, it will give a remainder. For the first iteration will be 1, then for the next iteration it will be 2, then for the next iteration it will be 3, like that. Then for the last iteration it will be 2, and then and for the second last it's 2, and for the last iteration it will be 1, right? So this is how it will give the remainder. And then we have sum is equal to sum into 10 plus remainder. What is this sum? Sum is the here is we have initialized as a 0 initially into 10 plus remainder. Remainder will be here, what we got here after using num modulation, right? So we will get remainder here and it will be added into this into multiplication, right? And the value will get updated for the sum. Okay, and then num is equal to num divided by 10. Okay, so for each iteration this number will get reduced. So initially it's this one, right? So when we divide that number with 10, it will be 1 2 3 2, 1 will go away, right? For the next iteration again 1 2 3, like that. So number will keep reducing for each iteration, like this. Okay. And for the next iteration what will happen, we'll get remainder is equal to, okay, so let's understand the first. For the first iteration we'll get remainder as 1. If we for when we use num modulus 10, we'll get remainder as 1. Then sum is equal to sum, initially sum is 0 into 10 will be 0 plus remainder is 1, so 1. So value of sum will get as a 1, right? And num is equal to num divided by 10, we'll get 1 2 3 2, like this. For the next iteration remainder is equal to, number is now updated 1 2 3 2. So again 1 2 3 2 modulus 10 will be 2, we'll get remainder as a 2. Then sum is equal to 1 into 10, 10 plus remainder now we got as a 2. So 10 plus 2 is 12. So we got sum as value as a 12, like that. Then sum is, num is equal to 1 2 3 2 divided by 10 will be 1 2 3, like that. Again it will be checked here, 1 2 3 is greater than 0. So conditions are satisfied, loop will execute. Remainder is equal to 1 2 3 modulus 10, will get remainder as 3. Sum is equal to 12 into 10 is 120 plus remainder we got 3, so it will be 123, like that. And then num is equal to already number 123 divided by 10, it will get as a 12. So like this it will go and at the end we'll get number as less than 0, less than or equal to 0. So condition will not satisfy and will not execute the rest of things. So at the end we'll get as a 1 2 3 2, and then 1 2 3 2 1, like that. So the given example is a palindrome number, right? So in the if else condition we will check num1 is equal to sum, and num1 is the original number we have declared is equal to num, right? Because num is getting updated every time here, so that's why we can't use num. We will use num1 is equal to sum. Sum is the final output, right? So if the number is equal to sum, then we will print num1 is a palindrome number, and if this condition fails, then we will print in the else num1 is not a palindrome number. So this is the code to check whether the given number is palindrome or not. Let's execute and check. 12321 is a palindrome number. So now let's make it a change. Let's remove the 1 and check. So it's not a palindrome number. So 1232 is not a palindrome number. Yeah, this is how we can check whether the given number is palindrome or not. Yeah, that is it. Thank you. So in this video we'll discuss about a sum of the digits. So this is our number, and we will add all the numbers and we will get the sum of all numbers, which is currently 8 for this example. So we have to write the code to check we to get the sum of the all digits, right? So this is our main method, and integer number is equal to 1 2 3 4 5. So we have taken this number, and integer sum is equal to 0. So this is the another variable. So we have number and sum, two variables, and we have one while loop here. So the condition of the while loop is number is not equal to 0, then only this loop will execute, and when the number is equal to 0 or less than 0, then this loop will not execute, the condition will fail, right? Okay, so let's understand. Inside the loop we have integer digit is equal to number, this number modulus 10. So for each iteration we will get a remainder. A remainder means we'll get 5, we'll get 4, we'll get 3, like that, 2 comma 1, like that. So for each iteration what will happen is this number will be used and modulus will be 10. So number modulus 10 will get remainder will be 5 4 3 2 1, like that, right? Okay, so for the first iteration we got remainder as 5. Then sum is equal to sum initially sum is 0, so 0 plus digit, so digit value we got as a 5, so 0 plus 5 will be 5. So for first iteration we got sum as, so the value of sum will now got updated to 5, right? Okay, again number is equal to number, this number divided by 10. Okay, so here number will update it to 1 2 3 4, the right. Okay, then for the next iteration again the condition will be checked. So number is now 1 2 3 4, which is not equal to 0, the condition satisfied. Again here digit will be 1 2 3 4, modulus 10 will be 4, right? We get a remainder as 4. Now digit is 4, sum is 5, so 5 plus 4 will be 9. Okay, so the value of sum got updated to 9, right? Then number is equal to 1 2 3 4 divided by 10, we'll get as 1 2 3. Okay, for the next iteration again 1 2 3 is not equal to 0. Yes, condition satisfied. Again integer digit 1 2 3 modulus 10 will get 3 as a remainder. Sum is equal to 9 plus 3, it will be 12. Again number is equal to 1 2 3 divided by 10, will get as a 12. Then 12 is not equal to 0, condition satisfies. Then digit is equal to 12 modulus 10 will get as a 2. Then sum is equal to 12 plus 2 will be 14, right? Again number is equal to 12 divided by 10 will get as a 1. Then 1 is not equal to 0, condition satisfied. Here 1 modulus 10 will get 1. Sum is 14 plus 1 will be 15. So we got final sum as a 15, right? And number will be 1 divided by 10 will be 0. So now we got num as a 0, number as a 0. So the condition satisfied here. So the condition will not satisfy, the loop will not execute now, because the value of number is now 0, so loop will not execute forward. Okay, so and at the end we are using printing statement, sum of the digits will be sum, so we got final sum as a 15. So this is how we will get the sum of all the digits inside a number. So let's execute the code and check whether we have written code correctly. So the sum of the digits is 15. Yes, we are getting the sum correctly. Yeah, that is how we can get the sum of the all digit. Yeah, that is it. Thank you. Hi everyone, so in this video we'll discuss about how to find the digits count of a number. So for example, this is our given number and the digits count for this number is 5. So we have to write the code to check the digits count for the given number. So this is our main method, and integer number is equal to 1 2 3 4 5, and integer count variable is equal to 0. So we have taken two variables, number and count. So count is equal to 0 initially, and then this while loop is there. So the condition for the while loop is number is not equal to 0, then the condition will execute. When the number is not equal to 0, then this loop will execute. And here there are two lines of code inside the while in the loop. A number is equal to number divided by 10 and count plus plus. So for each iteration number will get divided by 10 and the number will get reduced here for each iteration, like this, and the count will be increased by 1 for each iteration, right? So this is how we are finding the count of the given the digits count for the given number. and at the end what will happen, the number will get divided by 10 and it number will become 0. So when the number is 0, so this loop will not execute and the count will be stopped here. This loop will not execute, right? And at the end we will be printing number of digits is equal to plus count. So let's execute the code and check whether we have written code correctly to check the digits count for the number. So digit count, number of digits is equal to 5. So let's change the number to something else like 1 3 2 4 5. So it's 4, right? So it should print 4. Yeah, that is it. We are getting 4. So yeah, this is how we can check the digits count for the given number. Yeah, that is it. Thank you. Hi everyone. So in this video we'll find the maximum number among three numbers. So for example, we have numbers 20, 15, 12. So the maximum number is 20, right? So we have to write the code to check the maximum number among the given numbers. So this is our main method, and inside this method we have three variables: integer a is equal to 10, integer b is equal to 25, integer c is equal to 15, and we have if conditions here. So in the if condition we have written code to check code here. So a is greater than equal to b, and a is greater than or equal to c. So when these two conditions are satisfied, when these two conditions are true, then we will print largest number is a, because when a is greater than or equal to b and a is greater than or equal to c, then obviously the largest number is a, right? Again, in the else if condition we have written b is greater than or equal to a, and b is greater than or equal to c, then largest number is b, right? Also in the else condition, it will be c now, because if these two conditions are failing, then obviously the largest number will be c. So let's execute the code and check whether it prints correctly. So now change something to, let's make it as a uh, 20, let's keep it as a 20 and let's make c as a 25. So it should print now 25 as the largest number. Yes, this is how we can find the largest number among the given numbers. So yeah, that is it. This is very simple and you can easily write these conditions and find out the largest number among the given numbers. Yeah, that is it. Thank you.